My Swedish is non-existent, so I have to do it in English. I don't have an excuse. So I hope you can follow me. My name is Erik Steenken, 26 years with Shell, particularly in the latter years, going to more and more mature oil fields, where you had to be very clever in efficient operations. I then started my own oil and gas company, which was very successful. Doing exactly this sort of work, going every time a step further in efficient operations, and then I was called to help out here, and I'm glad to be here and helping Igrene to be successful. So I want to talk about the production test. Let me see whether I can manage this. So this is the content of what I will talk about. I'll talk about what we want to achieve. I'll show you where exactly it will be, what we intend to do during the program, what data we will be acquiring and why. I'll talk about the cost estimate and then what's next. Because at the end of the day, that's why we do this. So Vladimir explained that there is gas, that there is sufficient volume under the ground to put water or gas, but at this stage we don't know in what sort of form the gas is there. It can be in solution, just like your soda bottle. Yeah, when you open it, the gas comes out. There can be free gas down there, which there are indications that there is some free gas in the system going around, or both. And that's what we have to find out. And then we can also find out and predict better what we can produce. We can firm up some of the numbers that Vladimir mentioned. And we can then also start to predict how much you can actually produce from it in the future. These are the 4 key points that I show here. And the overall objective is obviously to safely, yeah. Remember, we're talking about gas, so we have to do this safely. Acquire the data to make an assessment on the commercial viability of this project. And I will be honest with you, it's going to be a challenge for us to make this commercial, but with clever minds and stepping out of the box, I think this can be done. Otherwise, I would not be standing here. Where are we? You've seen the big ring, the block. You've seen all kind of other maps. But if we zoom in, oh, sorry, my apologies. There we are. There's the little town of Mora, and just outside the town there is an area, which is this area, where there's some wood stored. Here are the wells we've been discussing. Vladimir 2. There are 2 wells already there, one shallow one and one a bit deeper. And this is where we would want to drill the new well. Yeah, I'm talking about the new well, and I'll come to that in a minute. This is the geology. Why do I show this again? I show this again because there is indication that there is faulting in the area. After a crater, after a meteorite hits the Earth, you get a lot of faulting. So it's no surprise that there is faulting, but there are indications that some of these faults are actually sealing, which is very important for the trap theory of Vladimir. And we do see these events between the wells, where you see those steps ups and step downs, particularly here. There's probably a big fault sitting there, and that means that the area may be subdivided in compartments, in isolated blocks. That's important to know, because it has a pro and a con. The pro is you may actually have the traps that Vladimir is looking for. The con is it could be isolated, and therefore the energy in that reservoir block may be somewhat lower. We need to find out. Yeah, but it's important to understand that these sealing faults are there. That's why I show this. This is typically a fault structure around the crater. I won't go into details there. But the faults that we are talking about, these black ones here, are these circular faults that are almost vertical and going down to the center of the crater. The other thing that the core analysis shows is, and Vladimir mentioned it several times, is that the area is heavily fractured also on microscopic scale. And these microscopic fractures can lead to reasonable production rates. And that's what we want to test with this production test. Now, what do we want to do here? There are 3 phases to the test we are proposing. The first one is to drill a new well. And you will ask immediately, why a new well? Well, we already have 2. Well, one is drilled with a very small hole, just to take the core. The second one is drilled not deep enough and has a configuration that's not ideal. And the second one was drilled to produce water to drill the first well. So we've decided not to take any technical risks, but to drill a new hole, which is probably on the bottom line cheaper than trying to go back into those old 2 holes. So we can make the hole just good for the production test, and that's what we're trying to do. What do we want to do? In more detail, we will install a surface pipe to about 20 meters. Normally you just you can hammer that into the surface soil. We will then drill a hole to 170 meters, that's important. And we will also cement that, because we will isolate any surface waters and protect them for the rest of the test and potential development. That's what I mentioned here with installing a steel pipe all the way to that area. And then we continue to drill to about 700 meters. We will clean out the hole because there's a lot of rubbish then, and we'll pump it all out. And we will install a wellhead. That's the phase 1. And then typically you will see that going down. We think it will be 4 to 5 weeks before we actually have that hole. Yeah, and here you have a diagram showing where the different pipes will be installed here. And this all is open hole. We don't do anything in there. And that's the end of phase 1, which is the drilling. The second phase is then get the data from the well. And we do that while we are flowing the well. What we want to do there is we will install a production pipe, and we will inject nitrogen in the space between the pipe and the steel pipes that we've cemented in, and then we will lift the well. Yeah, it's an air lift or a nitrogen lift we do. So you will immediately know how much can you actually produce from the well. And while we do that, we have tools in the hole. And it's like your gas meter at home. It's a spinner that goes around and measures how much is being produced. And we will log the whole, you call it log, you measure the whole interval, and you will see where fluid comes in and where there is no contribution. And we expect to see, maybe at the reservoir intervals, a little bit of contribution, but where the fractures are, you will probably see a lot of contribution of fluid. And maybe gas, we will see. That's the first step. Then the second step is we go back, yeah, and here there's a little picture how we do that. We have that's the wellhead. Then we have a wire line here on the drum with all kinds of electronics and recording devices, and we run that tool which is sitting there all the way down to 700 meters, and then we pull it up, and also actually bring it down again to also record that. When this is finished, we go out and we run a sampler. So we go back in, we produce the well slowly, and we'll take the samples on the spots where we see flows. And that will tell us what's coming in the well. Is it only water with solution gas, or is there free gas in there? So we'll capture that. We actually literally capture that, keep it under pressure, and we will send it to a laboratory to analyze. And then we pull everything out, and that's the end of phase 2. So it's all very short term. This will probably take 1 day or maybe 2. Very important data that we'll get here. Then the third phase is the actual production test. Here we start to produce the well for longer times. And we have chosen to install a so-called PCP pump, and that does not doesn't mean anything for you, but it's progressive cavity pump, where you have a spiral inside the housing, and by turning the spiral you actually pull the fluid up. That's what you do. And why have we chosen this? Because we know that there's quite some gas in the system, and with electrical pumps and other sorts of pumps you can't pump this. But with this type of pump you can actually pump it, and you can you don't have a problem with any gas that's coming up. It's a very simple system. You install a motor basically on top of the well, and then there's a rod going down all the way, and here's this worm basically sitting there, which you turn with the motor, and then the fluid comes up. And you can produce reasonable rates, and we're thinking about 400 cubic meters a day or something like that. We will install pressure sensors in the nearby wells to see whether after some time of production we see changes in pressures in the nearby wells. So you get a feel of how big it is, how sensitive it is, and how quickly the reservoirs are reacting. And then we will have a sequence of different rates, and that's an art. The actual production testing you need experts for. They will advise us how to do that, and we will do short-term tests for 2 days. There's normally 3 different rates, and then you close the well in and you look at the pressure, how quickly comes it up, does it come back, and then we do a long test of about a month here. I think I've lost my pointer. We have all the time pressure gauges in the hole, so when we pull everything out, everything is recorded, and we will look at that data. Now you see we have a facility here. Okay, here you have a sketch of how the test looks like. Very simple, a flow line to a separator where you separate water and gas, and the gas is being measured and the water is being measured, and the water is disposed, and that's it. Very simple test, and hopefully we will see what we see on the right hand side there. Now I'm stuck with my thing. That will help. So what data are we getting from the well? What you see here, this is the production test. 3 different rates, and then we close in, and then you see the pressure coming up to where, hopefully where it was. From that, with lots of computer power, you can analyze what the productivity of the well can be. So how much can you actually pull out? It will tell you if there are any compartments or boundaries in the neighborhood. Yeah? And it will tell you how strong the reservoir is. Yeah? How quickly will the energy be replenished. And the stronger it is, the more you can produce. Then from the logging, from the production logging, we will know where the producing zones are. We will know where the fractured zones are, and of course in the other wells we will be looking for them then. And we will know whether there's any actual reservoir contributing to production. And then from the samples we will get a good feel on the gas composition. So how much gas is actually in the in solution, and what type of gas is it. We will get a feel of the amount of gas dissolved, and if there is free gas, we will see that there. Yeah, and that's what you get out of all this testing. So in the summary, we are at this moment talking to the different contractors to do this. We want to finalize this by the end of March, early April. We are in the process of purchasing all this equipment, and we want to conduct the drilling and the testing in the summer of this year. Then there will be a period of study, understanding the data, and hopefully we are in a position by end of this year to declare commerciality, depending of course on what we measure and what we see, and how much of this big volume that Vladimir showed us is actually full with gas or water with gas, and how much will come out. We think that the cost of the test will be between 5 and 6 million SEK. And the question then is, of course, what after that? After the test, and as soon as we get positive indications, we will start to engage with all the stakeholders in the region, authorities, customers, whoever, such that everybody is aligned, and we take them along in the project. We will obtain the different permits. We will prepare the contracts with the customers. We will arrange for further financing, and we want to then start to develop a first energy bank, which is a multiple of wells something like between 7 and 9, maybe 10, depending on how much they will produce. And then we will prove economic feasibility on a larger scale. So it's a step-by-step approach. First is test, then an energy bank. And at the same time we will continue to explore and find other more-like areas in the neighborhood. And they're there, no doubt, but we'll have to find them first. Yeah. And that's more or less what you see in this little project chart on the bottom, where the important points are, of course, this test here. And then whilst this gives a good feel, we will be preparing, and that's the moment we want to decide, and it's all depending on the permits. I'm very open to that, of course. But somewhere in 2016, maybe mid-2016, we want to take the decision to invest in a full bank, the first energy bank. And then we will explore at the same time, and depending on the successful exploration, we will develop the other banks at the same time. And that's really the part that I wanted to share with you here. Any questions?
You mentioned that you sign up as customers in the middle of the process. Who are the potential customers?
There are Aeon is a customer that needs heat. The water has heat. We are looking at possibly generating electricity, local, domestic electricity, or for the industry around Mora. Or we are going to look at liquefying the gas, or compressing gas, compressing gas as CNG. And that can be used in cars and industries and biorefineries and whatever.
So in the beginning it's local?
It's local. It will be initially local, yeah. The more you have to transport, the more expensive it gets. So we will start local, and if it's getting bigger and bigger, yeah, of course, then we'll see where this goes. But in these sort of projects, you have to be humble. Start small and see how you can grow.
Or the community involved today?
We have started the discussion and are informed that we proceeded the whole time. The country government was started the process.
Yeah. You said you have the investments decision. What kind of calculations are you doing during those two, which you mentioned in the chart?
Well, we need to. The first decision will be how much can we actually produce. So we'll have to make an estimate on the production forecast, not only for next year, but over the next 10, 15 years. And we need to do that not for one well, but for 4, 5, 6 wells. So you get a production forecast. And normally you have a range in that forecast. So there will be a mid-case forecast and maybe a low and a high case. But once you're comfortable with that, you continue to work with the mid-case. And then you need to look at your capital expenditure. And here typically we stay away completely from the oil and gas industry. We try to do this in an alternative way. Local supplies. There's quite a lot of knowledge on utilizing heat in Sweden and in Iceland and those places we're looking for. Everything is aimed at reducing the costs during the capital investment phase, and the operating cost must be as low as possible. And there you look at automation, at minimum manning, at selecting equipment that does not need a lot of maintenance over time, minimizing failure. That's the whole package that you will be working then. And then you come, when you're comfortable you can do that, you come to your investment decision for an energy bank.
But you're just trying to see, you would have some kind of market price.
Yeah.
And if you have that market price, then you can drive two calculations. Either one where you say, okay, this is the investment I have to do in order to produce that market price, to get that available for the customers. And then you can say, I need this return on investment. And then you can see, do I have that volume or not?
Do I have that production?
No, yes. Do you have that volume?
Yes, you can do it. Yeah, yeah.
And then, of course, you have to
yeah.
judge. Or the other way and say, if I have my calculations for the volume, how much can I invest?
Yeah.
And that's then
And these calculations have been done.
they have been done.
Have been done. We have a feel. We have a very rough approach to the forecasts, and we know that with a medium case, it's just making it at this moment. But we will test. We are hopeful we'll get the better porosities, and but it will be an economic challenge, no doubt. Yeah. But the indications are that we can probably pull this off.
I guess during the history of Igrene, it's a way of saying, okay, I take the risk. Now you have Vaxitoria and get the new funding you said has been reached, and you have money to do this production well. I guess next time the market will be much more demanding on what is the security rate and what's the risk taking.
Sure.
So yes, we're approaching critical.
But hopefully next time we can stand here and say, look at the production test.
Which is the end of this year somewhere, I guess.
Yeah.
I just would like to remind you we're